check what's happening here. Blip, 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 blip. Okay. Are we streaming? We are. You know, I should. I should, yeah. But, yeah, don't bother with that, but at least have it ready, right? No?
we go.
Yeah, we sent it to the email that was on file there. Let me just...
All right. Good morning, everybody. Welcome to our Thursday class. Seems like there was a
I can
conversation
transfer,
going.
if you're looking for your QSVN, I can transfer you to someone else.
Okay, I think she's talking on the phone, so I had to mute her. The problem with muting someone on my end is I might forget. Oh, another mute then. I might forget to unmute you. That is the problem. And what if you have a question? Super important. So that's why it's good to manage your background noise and microphone on your end. Anyway, welcome. We are slowly easing into things, just taking our time. A lot of this is review. Now, some of you might remember these things very well, and some of you might not. I seem to have disappeared off of the camera. It's okay. You can watch a out of focus nature webcam today. Pretend I'm there speaking. So, because not everyone remembers these things perfectly well due to time or for whatever reason, it's good to ease into things and just review the important aspects, things that we'll take with us into the chapters where the calculus begins. But that doesn't mean it's going to be super simple for everyone. So if you have a question, that's why we're doing it. So please ask your questions still. All right, so we are going to talk about linear equations or linear functions. It's very important in general to understand the difference between an equation and a function without getting into too much detail for our purposes. It's for our purposes largely, it's all just about the focus. I said that last time. It's what your focus is, how you want to view the um, information. There could be uh, an equation like whatever x plus y equals 7. That gives me information about how two variables are related to each other. And they're sort of on equal footing if I view it in the equation, uh, on the equation side. Whereas a function, I want to see an input resulting or leading to an output, 7 minus x in this case. Now this guy over here, or I'm going to want to say it in brackets, curly bracket, is equivalent to y. It's more just how do I want to view the information? Do I want to see the two variables on an equal footing and understand their relationship in an equation? Or do I want to see it as input, calculation, output? For our immediate purposes, until much later, there's no difference between these other than the focus. Okay, so we want to look at a specific type of equation, anything that has what we call the general form, some constant times my variable, some other constant times my second variable equal to some other constant. So I have a, b, and c specific numbers. X and y are the variables in question. A, b, and c are the constants. Just because I like to do it out of habit and to alleviate my paranoia, I just want to check. Let me know in the chat that you can, in fact, hear me and see me and everything is running as it should, just for my peace of mind. That looks like a weird B. It's supposed to be a T and an S. They are constants. Okay, perfect. All right. So we have this specific kind of equation that we call a linear equation. When we try and visualize this by looking at two number lines, the number line for the x values, let's label it over here, called the x-axis, number line for the y values, we'll do that vertically, called the y-axis, and we look at a specific, all the possible x, y pairs corresponding to points in this plane that satisfy an equation like this, we get some sort of straight line depending on the a, b, and c values. But it's always going to be a straight line graph. Of course, I would need to know the specific numbers. Now, this is just review because you would have seen this before. It's not a pre-calculus class. It's just a little brush up like, oh, right, I remember this. Okay. Or, ooh, I don't remember this very well. Let me go and review in my own time. It's just sort of raising our awareness. It's always a straight line graph when the equation looks like this. We have two important points, the x-intercept, where the straight line graph intersects the x-axis, and that is when x, not x, the corresponding y-coordinate is 0, and we have our y-intercept, and that is when the x-coordinate of the point is 0. So if we have a specific example, we can find the x and the y-intercepts. Can I squeeze it in here? I don't want to. Let's make a new page. Like that. My example is not something in the problem book yet. I'm just making one up. 2x plus y equal to 4. Linear equation because it fits that general form. X-intercept. I'm going to set y equal to 0. And then I get 2x plus 0 equal to 4. So x is equal to 2. I'm going to leave a little space and start my graph because I have information. I want to put it in on my graph. But I still, of course, need to do the y-intercept. That is not a line. There we go. Big arrow. X and y. So my x-intercept is 2. Let's put 2 over there for no reason whatsoever. Then I also want my y-intercept. That's where I set x equal to 0. And in that case, I have 2 times 0 plus y equal to 4. So y is equal to 4. and I have my y-intercept, let's say, over there. Because it's a straight line, I just need 2 points that I can connect, and that specifies the line uniquely. Now, with my straight line tool, I'm going to do it in 2 pieces so that it actually looks straight. Otherwise, my guessing is going to be a disaster. Like so. And there we go. There's our straight line corresponding to the linear equation. Okay, hopefully everyone remembers this fairly well, but if you don't, we're doing it so that we have the time to remember and ask questions as we need to. So even though things are supposed to hopefully be fairly simple, that doesn't mean you are not allowed to ask questions. All right, so I want to note one important aspect of this linear equation, this straight line graph, and I'm going to call that the slope. The slope is an indication of how steep this line is, the angle that it makes uh, with the x-axis and the y-axis. And we're going to define the slope as the change that I have to make in the y value, in this case 1, 2, 3, 4, for example. And to get back to the line, I would have to make a change of 2 in the x direction. So the slope is a ratio 4 to 2. And that ratio is going to be where it's convenient, maybe the intercepts, but anywhere else as well, it's going to be a 4 to 2 ratio. It could maybe be 2 steps and then 1 step. That 4 to 2 ratio, or simplified 2 to 1 ratio, is always going to be the same regardless of where I am. If I move away from the line, I have to move back according to that slope, that ratio. So now it's the change in y over the change in x. So in this case, the slope is going to be 4 down, so it's a negative 4, 2 in the positive direction for x, so it's going to be negative 2 when I simplify it. When I, whoopsie, when I simplify or not, it is already pretty simple. What I mean by simplify is when I solve for y in this general form, I'm going to get y equal to negative 2x plus 4. And that number in front of the x is the slope. It's always going to be the slope. Also note that this 4, the constant term that I get when I solve for y, is always going to be the y-intercept, because I get the y-intercept by setting x equal to 0, and then I would exactly get that extra constant term. So when I solve for y, solve for y in the linear equation, I'm going to get the what we call slope intercept form, and in general we write y equals mx plus b. An alternative to the general form that in my opinion is a little bit more useful because the numbers that feature in that equation directly corresponds to things and properties on the graph, whereas the original general form of the linear equation doesn't show me immediately what those numbers mean. I had to do a little bit to find out what all these numbers is, especially if there's something in front of the y. But when I solve for y, I now have it in more of a function form. that the input x results in a corresponding y value. The slope gives me a proportional change of one to the other, and the b gives me the y-intercept, or when x is equal to 0. All right. Does the slope-intercept form look familiar to some at least? Oh, I see the polar bear's back, but he doesn't want to look at me. Let's see if we can reset him. Nope, he does. He just wants to look in the corner. He's shy today. He doesn't want to make eye contact. We understand. It's okay. You do your thing. Okay, so we have our slope intercept form. Change in y over change in x. Slope and y intercept. Now, the discussion might start at the general form, but after I have the slope intercept form and I understand how nice it is and the fact that I have immediate meaning for those numbers that I see, I don't have much use for the general form anymore, and the slope intercept form is the only one that I need. I know in pre-calculus, if you remember very well, you learned about other forms, the point-point form or the slope point form and all those things. They're not very useful, to be honest, other than giving you variety in examples and questions. There's nothing that I need them for that I can't handle with the slope intercept form. So this is the only one I care about because I don't need anyone else. Why would I bother remembering other things when they don't add any usefulness? So now let us go to the problem book. Let me just make a new page here. Problem book. Whoops, too much. Now the problem book is of course available on the course website. Let me make it a little bigger. I'm going to go to problem 1.1 number 4. Oops, bigger zoom. Oh, that's the introduction. Where are the problems? 1.1 number 4. Where are you? There you are, nice and big. Okay. So we want to construct the linear function, and the linear function is necessarily going to be the slope-intercept form. It says that find the slope-intercept form of the line with the given slope, and it passes through the given point. So let's do it. Just checking if I'm missing any questions or messages. It's very quiet. I like to have some interaction, if nothing else, to confirm that technically everything is working and audio and video is all good. So we want to do problem 1.1, number 4. I'm doing great. I thank you. I try. I try my best. I try my best. But I don't honestly know what other instructors, other people do and how they do live classes. So hopefully this is as user-friendly as it can be. But I always value any criticism or opinions or anything that you've seen that might work better and we can improve. 1.4 number 1.1 number 4. Okay, so I opened the book here. Yeah, it's good to know. I don't really know many other systems because for a while I was sort of jumping between universities and everyone had their own system and I had to relearn everything and none of them were really super efficient and I was just like, I'm gonna stop when YouTube, Discord, those things are used by millions, if not more, millions of people. Why? They can't be wrong. Okay, so we have a slope of, let's say here, given. So I remember given my slope, I have to remember these things, right? Jump back and forth. 2 over 3. 2 over 3. And my point, that is also on the straight line, -2 and 1. I don't care what the point is called. Okay, so we start with y equals mx plus b, my slope-intercept form, my function form, whatever you want to call it. That's the best one, the only one I need. So the slope is already given. So we can just insert 2/3 right there. So we can update to y equals 2/3 x plus b. So now I still have to find the b. Now remember, the slope-intercept form is still an equation, just like the general form was, which means it gives me a relationship between x values and y values. So whenever I plug in an x and a y value pair that is valid, that sits on the line, it has to satisfy the equation. So I can use the point -2, 1 and say, well, when y is equal to 1, x is equal to -2, and that equation has to be true. So I have simplified -4 over 3. So b is 1 plus 4 over 3. So that's 1 1/3, so 7 over 3. Now I can go decimal here, but then I have to round it, and I don't want to do that. It might not look ideal. So let's just leave it as a fraction. My slope is in fraction form anyway. So finally, I have what they're looking for. Y equals 2/3 x plus 7 over 3. Let's put a box around it. Feels nice. Now, do they ask me to graph it? No, but let's do it anyway. It's not ideal with the fractions, but it is what it is. Okay, so technically, whoops, that is the end of the question, but it's nice to visualize. Actually, I'm gonna, I don't know if I want to mess with this one since the question doesn't ask it for a good reason. Let's leave it for now. I think the next one might be simpler. We've answered the question. And again, I don't care about any other. Oh, but I have the slope and a point, so I should use the slope point form. No, I don't care at all. At all. I'm just getting used to um, the slope and the slope intercept form, trying to remember and noticing that I don't need anything else. Let's do one more, and I want to do problem 1.2 number 4. Problem 1.2 number 4. Oh, so both number 4s. Okay, let's go there and look at it first, just in case you aren't able to jump back and forth as easily. So again, I just have different information. I want to do the same thing. Number 4, I have 2 points, 3, -5, 7, 4. So I'm given 3, -5, 7, 4. Let me just double check. I did read it just now, but so easily I can mix it up. Okay, so again, yeah, it's 2 points, so I should use the point for. No, I don't remember those things because I never need them. I start with 1, and it's the slope intercept form. Unless the question asks for something else, which it won't, because I set up the questions, there's no need for anything else. They're all equivalent anyway, up to simplification. So if I start with the slope intercept form, it means I'm going to have to find the values of m and b. I like to start with the m, so that would be my slope, m, remembering that it is the change in y over change in x. Sometimes people write delta y over delta x. Maybe you've seen that. And delta is just the symbol for the translation for change in. It's all the translation between languages, right? Now I can mix the languages. There's no harm in that. And that's often how we speak if we, in certain countries, you mix languages, mix words all the time. This is no different. But it's nice to see the delta if you so choose. So now I'll just pick a first and a second point because I'm changing from one to the other as I walk along my straight line. We'll see the line in a second. So the change is end minus start. Whoops, y is first, right? Not x. If I want to do x, x goes in the bottom. End minus start. Y is the second coordinate. Change in y, end minus start. This is going to be a fraction again, isn't it? Man, they just love their fractions. So I get, yeah, 9/4. So a change of 9 units vertically correspond to a change of 4 units horizontally. All right. I update. Feels like I'm going too fast. Feel free to stop me if you feel this is too fast. Just because it's review doesn't mean we remember everything perfectly. That's why we're doing it. I update to 9/4x. I still don't know the b. Fair enough, but I'm getting there. All right, everyone happy so far? I can't tell from silence. Okay, good. Silence can mean anything. I don't even see anyone's expressions to try and guess how you feel, but hopefully everything is good. Now I have to find the value of b, and I can use either point, just like we did last time. Use a point that has to satisfy the equation. I've just picked the one that looks nicest. I don't know which one really looks nicest. One or two, they both look unpleasant. Maybe the one without negative numbers. So you might choose the other one, but the result will be the same. Maybe I'll use 7/4. Was it 7/4? Why 7? Man, fine. Plug it in. Has to satisfy the equation. 4 for y. 9/4 times 7. That's going to be fun. Plus b. All right. Now we could do it. Stick to the fractions. There's no harm. You could do it on your calculator. B is regardless. Let's leave it exactly like that because I want to demonstrate something. So exactly like that. Do whatever you want to do here. But if we want to practice our calculator use, I want to just demonstrate that we have a calculator in the chat as well. Let me just practice and demonstrate it first. It should show up. I just have to type two equal signs and hopefully it's awake and ready to go. If I just do a simple 2 plus 3, is MathBot awake today? It is awake. Okay. So let's suppose I don't want to bother with the fractions. I don't care to keep it in fraction form. I just want to do it. You can actually do it in the chat box as well. You can make your own chat box, whatever. Let's do it. 4 minus 9/7 times, no, 9 times 7/4. As the B calculation requires. And we have negative 11.75. Let's suppose I didn't even care. I can convert that to a proper fraction. Who cares? I don't care. Doesn't matter at all. We can then update finally. No one says we have to write decimals or fractions. We can mix them. It's all correct. So every now and then we'll try and use the calculator so you can see it in the chat box as well when you watch the video again. It's very useful. So we have our equation in whatever version you want. You could change the 9 over 4 to a decimal as well. I just like the slope in fraction form for graphing purposes. We'll show in a second. It's going to be a minus 11.75. So the negative 11.75 is my y-intercept. It doesn't really matter that it's a decimal. Now I know my question is done. They don't ask for the graph. In problem 1.3 they do, but I might as well do a graph for this one. Let's set it up. And again, it's just a very rough visualization. It doesn't have to be perfect in any way. So our y-intercept, let's just put it over there, negative 11.75. I have a positive slope. Notice that it's positive. So that means a positive change in y, so up is positive, corresponds to a positive change in x. So to the right is positive. So that means if I go 9 steps up, that's going to get me to negative 2.75 in this case, because I like to go from the intercept towards the center. You don't always need to do that. It's just easier to put things in the right place. So 9 up would correspond to 4 to the right. So that gives me a point here with an x-coordinate of 4, because I was on the 0 x-coordinate, and negative 2.75. Let's connect them. I just need 2 points, then I can connect them. And I had a y-intercept, then I used the slope to travel wherever I want, as long as I travel in a 9 to 4 ratio. Now in this case, that doesn't give me the x-intercept perfectly. Maybe I want to find the x-intercept. I'll do that in the old-fashioned way. Set y equal to 0. Then I get something not completely pleasant, but it can be done regardless. So x is going to be, move the 11.75 over, divide by 9 over 4, and let's see what we get. And if it makes sense that it's a little over 4. I can't tell from my graph exactly how much over 4. Is it 4 point something? Do I actually get to 5? Who knows? That's why we have to calculate it. So we put 2 equal signs there, 11.75. That'll be divided by 9 times 4 because of the fraction. And in this case, it turns out it was a little over 5 actually. 5.2 repeating. I'll put a little line over it. So that's that x-intercept over there, if they happen to ask for it. But they didn't in this case. I just wanted to be complete to see everything there is to see. All right, so that's a pretty standard example of some information, and I have to come up with a linear function, linear equation, maybe graph it, maybe use the slope, maybe find the intercepts, all those good things. That is hopefully somewhat familiar. I see the polar bear is still extremely shy. That's okay. You look down, buddy. We don't mind. Okay. Now I just want to note a couple of things. What did happen to this line? Get out of there, line. Couple of things before we finish this little review session. And again, like I said before, if we'll go a couple of days. That's completely review, and then we'll slowly bring in some slightly new things or some things that have a new way of looking at it. But as we're doing things that are supposed to be review and you feel like, oh, I don't know, I don't remember any of this, then that is a sign that you have to go and review a little bit more on your own. Get an open pre-calculus textbook and go nuts. But I can't necessarily say how much review you need. Everything we're doing in these sessions are things we have to know and will be carried forward. If it's not in these sessions, it's not that important for us in this course. So we have two special kinds of lines: horizontal straight line. I'll graph it. No, oops. I'll just use an example. Where is my pen? My pen is gone. That's not what I want to know. That's not what I want to see. Come on, where's my pen? Did I accidentally change colors? No, I'm in black and everything. It was just very slow apparently. Wow, okay. Now it's back. Okay, good. It doesn't like horizontal lines. For example, nope, I'm gonna make the line first. Let's make it pink or something. Horizontal line goes on forever, let's suppose at 2. What is the equation? The equation is, well, regardless of the x value, y is always equal to 2. You can plug in any x value into this equation. The y value is always 2. Now it looks special. It still fits the y equals mx plus b form. The slope m is just 0. And the b is, of course, the y-intercept, which is actually all the y values. So a horizontal line corresponds to a straight line with 0 slope. This is going to come up numerous times in the future. So very, very important. Everything I say is important, but if I emphasize it's important, then you know. Definitely important. The other one is a vertical straight line. Let's draw that. Set things up. Let's make it pink. Well, we've used pink. Let's try blue. Perfectly vertical. Let's say here sets at x equal to 3. That's just an example. It could be many, many different lines. Here, this one's different. This one has the same argument in that regardless of the y value, the x value is always 3. So my equation has to be x equal to 3. There's no real choice. But this does not fit the y equals mx plus b form, because this form necessarily has y equal to something, and there's no y in there. It doesn't work because there's no number in front of the y I can make 0 and have it disappear. It's not the same if I use this function form, which is totally fine. So I just have to remember that for the vertical line, it's really the exception that the slope is undefined, because the slope is change in y over change in x. So as I go from one point to the next, there's a change in y, great. What's the change in x? There is no change in x, so I'd be dividing by 0, and that can't happen. So talking about the slope of a vertical line makes no sense. It's undefined. Also very important. So even though, let me zoom out, even though the horizontal line technically fits into the slope intercept form, it's not a super special case. I do see it as special and different, but it just has a special slope of 0. The vertical straight line is very special in that it doesn't fit that form and the slope is undefined and it's very different than all the other kinds of lines. Okay, so I definitely want to be aware of these two special cases, and I want to be able to understand the slope, graphical interpretation of the slope. Can I find the slope intercept form of a straight line equation, linear function, whatever I want to call it, and graph it? But still, we're not doing the full pre-calculus topic, so we just want to be able to do the basics. All right, are there any questions on this? I'm just, okay. If there aren't any questions, then we will end the video here, but I want to emphasize what is happening tomorrow and look at the schedule briefly. Just want to bring up the schedule here. Tomorrow is Friday the 11th, and you'll see if you look at the schedule, there's a yellow box, which means that is not a live session. That is one where you have to watch the video called Linear Function Applications. It's it's a lecture, but it's one that you are going to watch in your own time, at your own pace, pause it, rewind it, go as fast or slow as you want. See if you have any questions. The video is already in our playlist, so that is what is happening tomorrow. Always consult the schedule to see what's happening. At 12:30, we have a live Q&A session. Attendance is completely up to you. You come and go as you wish. If you have questions, that's what that time is for. If you don't have questions, that's totally fine as well. We haven't done much. If you have technical questions about how to use Discord or YouTube or whatever, feel free to bring those questions. It's just there for people to catch up if they need to. Everything is in our playlist. The information on the playlist is on the course website. Every detail information is on the course website in our YouTube playlist. You cannot miss it. It is called exactly the same as our course. So that is what's happening tomorrow. And every week is a little bit different, so always consult the schedule. Any questions on that? The recorded lecture from yesterday is also in our playlist. I put the live stream that's automatically backed up to YouTube in the playlist right away, but then I also edit the video to make it a little bit more watchable, and that sometimes has a delay. I can only get to the video at in the evening, so it's a little bit later. There is no attendance. You are not in school anymore. I am not holding your hand. I am not checking up on you. We're all grown-ups. You attend what you want, when you want it, as you want it. I'm taking no attendance. We're all grown-ups and can be responsible for ourselves. All right, any other questions? Well, if you think of anything, we have some Q&A sessions tomorrow as well. So do not be confused. If there is no live lecture at 11:30, look at the schedule and eventually we will catch up to how this is done. Thank you very much for those that have attended. Hopefully the material will become a little bit more challenging or new, and you can interact a little bit more because it's definitely more fun for me and more fun for you if we have more of a discussion and questions, but that's totally up to you. All right, until maybe tomorrow. Maybe I see you tomorrow. Maybe I see you next week. Totally up to you. Until then.